Hi there everyone. So this video is going to talk about another type of restriction. So we've been talking about domain and range and set builder notation and restrictions. And now we're going to talk about point restrictions. So I suppose the best way to draw a point restriction, or the best way to talk about point restrictions, would be to draw one. So I'm going to draw a graph with a couple of different point restrictions here. Now, point restrictions can occur in a couple of different forms. One of the forms is from an asymptote. So you may recall from dealing with reciprocal or rational functions that asymptotes can occur. And what would happen is the graph would approach the asymptote from one point and go up. And then it would approach the asymptote from another point on the other side and maybe go down. It could even go back up again. There's many different things that can happen. So this occurs when you have something like this would occur when you have something like a dividing by zero occurring. So let's say that this asymptote here exists at the value of 2. So if your function was f, we could say that f equals something, and I'm not going to say exactly what it is, so I'll leave a parameter a. So that could be just any constant. But I know in the denominator, somewhere it's going to have x minus 2. Because if I substitute in 2, I'll have a divided by 2 minus 2. And what's anything divided by 0? That's right, it's nothing at all. And in fact, it allows you to start to understand what's happening at the asymptote. Suppose I used a number like 3 to start. A divided by 3 minus 2 is going to be positive 1, so it would show up there. And then if I got closer and closer to 2, I would have like 2.1 minus 2. So it'd be like positive 0.1. Well, that's the reason why it's getting higher. When you divide by a smaller number, things get larger, magnitude. So at like 2.000000001, I have a divided by 0.00000001. Challenge, did I say the correct number of zeros? I'm betting no. So if I did that, I would see a very large positive number because a divided by a positive number close to 0 is going to go up to 0. On the other side of this, though, if I tried a number like 1, I would have a divided by 1 minus 2, which would be a over negative 1, which is why I would have a value down there somewhere. And as I work toward my asymptote, I would still have negative numbers. Because think about like 1.9 minus 2. Well, that's negative 0.1. So in the same sense that 2.1 went up here, negative 1.9 is going to go way down there because it's going to be a negative value occurring. So that's an example of a point restriction that leads to an asymptote. So point restrictions tend to come from division. Which means to have a point restriction, usually you have to have some sort of rational function. Now it can appear to be a non-rational function, like a trigonometric function, like tangent or secant or cosecant, but it still is technically a rational function, because if you look at the identities that define those, you see that division will occur. If you checked out there for a second while I was talking about trig, don't worry, we'll see it much later, and we'll be able to get to it. So point restrictions come from division, but this weird thing happened with division in grade 11. Often we would consider an expression like this. So let's just consider h of x is equal to, I don't know, x squared plus x over x squared minus 1. And so you would have been given these expressions and said, okay, we'll simplify this. And they probably wouldn't have given you the function. They just would have said, simplify. Come up with the easiest expression. So your step would be to factor things. And remember, factoring is religion. We common factor first. So we'll common factor the numerator, be x and x plus 1. And then we'll factor the denominator as a difference of squares. And we're so happy when we see these because they're nice and easy. So it becomes x plus 1 and x minus 1 because differences of squares factor to a conjugate pair. This is the same exact binomial except for the signs. So at this point, you would have said, oh, wait, hold on a second. These cancel. And then, I guess that means that my expression is equal to x over x minus 1. And that's true, but you would also be told to put a restriction on here. And so when you're told to put a restriction on here, you would have said something like, well, because I divided by x plus 1, and you can't divide by 0, that must mean that x can't equal negative 1. And that's absolutely correct. X can't equal negative 1. And then furthermore, down here, we have another restriction because this remains in the denominator. So down here, we have something like x can't equal positive 1 as well. And that's if we're trying to restrict h of x so that it exists in the real numbers. So let's take a look at what a quick sketch of this might look like. Now you could graph this on your graphing calculators. Oh, what the heck? I've got my graphing calculator. Why don't I just do that right now? So I'll pull up my trusty TI-84. I'll turn the thing on. I'm going to go ahead and clear everything. I'll type y equals. This is where I'm going to type in my graph. So I'm going to graph x over x minus 1. I'll show you the buttons that I hit to do this. So I want to make a fraction. So I'll type alpha y equals, and that'll pull up my fraction menu. So 1 over d. So that was the green button followed by the y equals button to get your fraction. I'll show that again. Green, y equals, and you've got your fraction button. Now the variable that I'm going to use for x and x here is this x that's attached to the link button beside alpha. So this will be x over, and then in the denominator I just had x minus 1. And now I've got this typed in and ready to go. I'm going to press zoom just to make sure that my zoom is set to a standard zoom. So I want to zoom standard just so that I can see just that normal -10 to +10, -10 to +10. So I could scroll down to it by scrolling down, or if I didn't want to waste time scrolling down, I could just press the number 6 because that's what it is. And my graph will appear. And huzzah! Notice we have an asymptote. We have an asymptote at x equals 1. Now, why do we have an asymptote at x equals 1? Well, we have an asymptote at x equals 1 because we can't divide by 0. But we also have a weird thing happening at x equals -1. If I press trace, it'll allow me to read the coordinates of this graph as I move over. And I can just start sliding over and it'll read the coordinates for me. I could also press table and that would get me there as well, but I want to do this on the graph. So I'm going to scroll toward -1 and see what happens. I skip past it. I can't quite seem to get there. That's because of the resolution of my calculator. But what I can do under the trace menu is I can simply type -1 and you'll see that it changes my x location to -1. If I hit enter, it brings me there to 1/2. But wait, Gregoris, you said that x can't equal -1. Oh, well that's because we didn't graph h of x. We graphed the thing that h of x was equal to. Let's go back and we'll press y equals, and we're going to graph h of x as well, but we'll graph it on another grid. So we're going to graph this again. We'll press alpha and y equals to bring up our fraction. Now I'm going to type in x squared, and I'll use the squared button, plus x over, and then I believe it was x squared minus 1. And so now I have two things ready to go and graphed, and I'll click graph and see what happens. You'll notice, huzzah, it traces the original graph. Those of you who don't have color calculators, you may not see anything because red and blue is just black on your non-color calculator. I'm going to try that trace trick again. So trace, you'll notice that you can see the color here is blue. If I press the up, it'll scroll to the other graph. Now I can scroll over and investigate what happened at -1. Oh shoot, that same problem of resolution. Well, what if I just type -1 and hit enter? See how it leaves y equals as blank? That's because there's no value for it there. If I go to the other graph, and I go -1, I get 1/2. And if I scroll up and go -1, I get nothing. And these two graphs definitely overlap. So what's happening here? Well, what's happening is at -1, right there, there's a hole on the red graph. And you can't see it. And if you zoom as far in as you want in your calculators, you won't see it either. But what it looks like on an actual graph, we'll have an asymptote here. Oh, wow, I misdrew that. Let's just pretend that I'm better at drawing. Actually, let's actually get better at drawing. Draw this on the back. And so I have my asymptote. And I go through here. And now at -1, I have a hole. And so we draw a hole by showing a circled dot. The graph continues through it, but that just indicates that at the reasonable value of x, there's actually no point there. And so that's another situation where you have another restriction. This video is getting a little bit long, but I would like to do one last thing. So because we simplified h of x and we got to this thing and we graphed it and we showed that the graphs were equal because, well, as we saw in the calculator, they just overlap one another. Well, let's go ahead and draw out what the domain looks like. So our domain of h, the domain, it looks like it's the set of all numbers x that are elements of the reals such that, well, x can't equal -1 because of this division up here. And also, x can't equal +1 because of the division that remains there. Now, we say that this restriction is a removable or a hole. And we say that this restriction is non-removable. Or an asymptote. And that's restrictions, point restrictions.